Picture this, a cold gray morning at the airport, you're buckled in, ready for takeoff, snow gently falling outside, the engines hum, the cabin is calm, and passengers are lost in their own worlds. But outside, a silent threat lurks, a thin, nearly invisible layer of ice forming on the wings. In the cockpit, pilots are on high alert, scanning for any sign of contamination. They know even a dusting of ice can disrupt the delicate balance of flight. The ground crew gears up, ready to battle this unseen enemy before the plane can leave the ground. Passengers sip coffee, unaware that safety hinges on a detail as small as a layer of frost. For pilots and crew, the stakes couldn't be higher. A single mistake could spell disaster. Every inch of the wing must be perfectly clean, shaped exactly as designed. This isn't just routine, it's a critical defense against a foe that's plagued aviation since its earliest days. While the world inside the cabin is calm, a high-stakes drama unfolds on the tarmac. It's a story of physics, chemistry and teamwork, all focused on one goal, a safe takeoff. The plane waits, a giant held in check by something as simple and dangerous as ice. And every winter flight begins with this unseen battle, fought and won before you ever leave the ground. Why all the fuss over a little ice? Because an airplane wing isn't just metal, it's a finely tuned lift machine. The wing's shape is everything. Air flows smoothly over the top, creating lift. Add even a thin layer of ice, and that smooth flow turns turbulent. Suddenly the wing can't generate enough lift, and drag increases dramatically. Ice can freeze control surfaces, making steering impossible, like locking your car's steering wheel. Chunks of ice can break off and damage engines, risking catastrophic failure. This isn't just theory. Accidents have happened from seemingly minor ice buildup. That's why aviation's golden rule is the clean aircraft concept. No ice, snow, or frost on critical surfaces, ever. De-icing isn't an overreaction, it's a life-saving necessity. Every winter you'll see planes sprayed down even in light snow because the smallest amount of ice can have huge consequences. The industry learned the hard way, there's no such thing as a safe amount of ice. Safety means zero tolerance, every single flight. The difference between routine and disaster can be a layer of ice thinner than sandpaper. That's why the battle against ice is taken so seriously every time. Meet the ground crew, the unsung heroes fighting ice before takeoff. De-icing is a precise two-step process, not just spraying hot water. First, a truck sprays hot orange glycol fluid to melt and remove ice. Then, if it's still snowing, a thicker green anti-icing fluid is applied to prevent new ice from forming. This barrier clings to the wings, absorbing precipitation and shearing off during takeoff. In the air, planes use built-in systems, some heat wing edges with hot engine air, others use inflatable boots to crack and shed ice. Each method, chemical, thermal, or mechanical, reflects relentless innovation for safety. It's cold, dirty work, but it's vital. The people in those trucks are the guardians of your flight, ensuring a clean, safe start. Their work is the first line of defense against nature's frozen sabotage. Without them, no winter flight would ever leave the ground. Engineers don't just remove ice, they design planes to resist it. Aluminum, the classic aircraft material, is light and strong but gets cold fast, making it prone to icing. That's why anti-icing systems are built in, but they add weight and complexity. Enter advanced composites like carbon fiber, lighter, less thermally conductive and slower to freeze. But composites bring new challenges, integrating heating without weakening the structure. Engineers also develop special coatings like non-stick pans to repel ice. These coatings must survive UV, extreme temperatures, and high-speed abrasion. The quest is for materials that are strong, light, and ice-resistant. Every pound saved means more passengers or fuel, so the stakes are high. It's a constant balancing act: strength, weight, durability, and ice defense. The battle against ice starts long before a plane ever hits the runway. The future of ice defense sounds like science fiction. Researchers are developing ice-phobic coatings, microscopic textures that repel water and prevent ice from sticking. Some mimic lotus leaves, creating a cushion of air that keeps water from freezing on contact. Others use sacrificial coatings with antifreeze pockets that burst to melt ice from within. Next-gen heater systems use carbon nanotube films embedded in wings, heating surfaces efficiently with minimal weight. These advances mean lighter, more efficient planes that burn less fuel and reduce emissions. The goal: planes that shrug off ice naturally, no heavy systems required. The technology being tested today could make ground de-icing obsolete. Every breakthrough brings us closer to a future where the plane itself is the best defense. Safer, greener, and smarter skies are on the horizon. The science of ice is about to change the way we fly. At the heart of this story is material science, the unsung hero of aviation. Every leap in flight from speed to safety comes from breakthroughs in what we build planes from. Aircraft materials endure wild temperature swings, flex under stress, and resist corrosion, all while fighting ice. Scientists and engineers manipulate molecules to create alloys, composites, and coatings with near-magical properties. Chemists, engineers, and metallurgists collaborate to ensure every system works in harmony. The glycol and de-icing fluid, the carbon fiber in wings, each has a story of innovation. Next time you see a de-icing truck, remember the decades of research behind it. It's more than a job, it's a legacy of ingenuity and teamwork. Every safe flight is a victory over nature thanks to these silent guardians. The materials themselves are the steadfast protectors in the sky. Their science keeps you safe, every journey. The future of aviation safety is smarter, not just stronger. Imagine wings with sensors that detect ice instantly, triggering targeted heating only where needed. Aircraft will become self-aware, monitoring their own health and adapting to conditions in real time. Material science is enabling self-healing composites and wings that change shape for efficiency. The line between structure and system is blurring. The skin of the plane becomes a living, sensing organ. This relentless innovation is why air travel is so safe today. The battle against ice is a perfect example, always evolving, always improving. From brute force de-icing to nanotechnology, it's a story of human ingenuity. Every flight is a tribute to the scientists, engineers, and crews who make it possible. The skies of tomorrow will be safer, smarter, and more wondrous than ever. And it all starts with the science of ice.